You're listening to WMPG 90.9 Forum Portland Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the Astronomy Lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak. Go to WMPG.org if you want to find the last 5 weeks of archives of all of your favorite shows, including this one in case you missed them. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly. So this will be Friday, May 14th. So it'll be a waxing crescent moon. The new moon was back on the 11th when you couldn't see it for a few days. So this is the best phase of the moon because you can see a nice thin crescent setting right after sunset. You can look for the earth shine on the moon. That's actually sunlight bouncing off the earth. So for the crescent phases, you can see that. It looks like a ghostly image of the entire side of the moon that's facing us. It's probably hundreds of times fainter than the part directly lit by the sun that had just set. But you can see that, and you should look for it. And then basically, we still have Mars as an evening planet, setting around midnight. But Venus has joined it, so it will set a lot earlier. It's still low on the horizon. It's going to be getting better later on in the month and as we get more into summer. And then we have like a 4-hour gap, and then Jupiter and Saturn are coming up in the morning around the same time, about 4:30 or 5 in the morning. So that's basically it for the planets and the moon for this week.
Thank you, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. Today's show, we have Dr. Adria Updike joining us. And Dr. Updike is a current professor at the Roger Williams University in Rhode Island. She earned her PhD in physics from Clemson in 2010, and her dissertation was titled Gamma Ray Bursts as Probes of Dust in the Evolving Universe. We had her on a couple of episodes ago to talk about this research and gamma ray bursts in general. And because she had spent so much time with the telescopes in Chile, in Arizona, in New Mexico, our last episode with her was going through her life on the telescopes and a lot of the research that she did there. And this week's episode, we're focusing on some of the work that she's been doing currently pertaining to aquaculture and developing sensors and some of the other work that she's interested in doing in the future as well. This is the last installment of our conversation with her. And if you follow us online, we'll be leaving a footprint of, or a trail of all of our full conversation with her so you can learn more about Dr. Updike. Enjoy.
Had you also done some work on the two-mass sky survey, Adria? I think you did, right?
Oh, that was one of my very first projects. Yes. So my very first project in college, once I graduated from high school and moved out to go to college, I told my parents I'm not coming back, and they didn't believe me. They saved my room for years, but I was truthful. I never came back for more than 2 weeks at a time after I graduated. After I went off to college. So my very first summer, I got an internship working at UMass Amherst, which was right next to Smith College. And I was working with Steve Schneider, who was a member of the 2MASS team. So that's the 2-micron all sky survey. So it's an infrared sky survey. And basically they were looking at the entire sky. So it was a project between UMass Amherst and Caltech, I believe, was the other major contributor on that project. So basically mapping the sky in the near infrared. So basically my very first project was looking at the data from 2MASS and Arecibo data from the radio telescope that very recently, unfortunately, is no more in Puerto Rico. So we had 2MASS data and we were correlating it with Arecibo data, looking for galaxies in what we call the zone of avoidance. So back when people started mapping the sky, they eventually noticed that there was a whole big area of the sky in which they were not seeing any galaxies. So they've got galaxies here, and then a big empty zone. and they called it the zone of avoidance. And it turned out the reason for that was dust. There's a whole bunch of dust from the plane of our galaxy in that direction. So basically, they were looking along the plane of our galaxy, and the dust was blocking the visible light from getting through. But the dust doesn't block the infrared radiation or the radio. Those make it in through the dust. So basically, we were looking for galaxies, large spiral galaxies in that zone of avoidance behind the dust to complete our map of galaxies in the universe. So we were correlating the 2MASS data along with the Arecibo data, basically just searching through the sky, looking for the signature of rotating spiral galaxy. So basically, you'd get a big spike from the gas in the galaxy, and it would be Doppler shifted because the galaxy is rotating. So you'd actually have this double peaked spike that you'd come out from a big galaxy. Unfortunately, the frequency we were looking at was almost the exact same frequency as GPS satellites were broadcasting on. So sometimes you get a galaxy and sometimes you get a giant spike from the GPS satellite instead, right in the middle of your data.
That's pretty good. So how many galaxies did you find?
Just luck of a draw. My specific project, I might have seen 50 galaxies for the first time that summer. I'm not sure. I don't know if I ended up on any publications from that. Maybe thanked in a paper somewhere. Yeah, it was pretty cool to be the first one to see something. And then again, it happened with the gamma ray bursts. Every once in a while, I was the very first person to report that we saw a new one for the first time.
Oh,
That's awesome.
must have felt like Clyde Campbell
when you said
Pluto.
Something like that.
Yeah. Oh, that's pretty neat.
when you're talking about the zone of avoidance, what kind of area are we talking about in terms of like an area of the sky where you would say there's nothing there?
Yeah, so it was basically along the plane of our galaxy. So it would wrap all the way around, I don't know, like 10 degrees out in each direction, and then with a bulge in the middle. So it was basically the center of our galaxy and the spiral arms of our galaxy. All the dust in them were blocking this area. Yeah. So the zone of avoidance, I don't know who came up with that term. It was probably a very melodramatic way of putting it. Yeah.
No, for sure. That's I think somebody had described a gamma ray burst as the birth call of a black hole. Like kind of like how when a baby is born, they start crying. That was how they described like that's like the birth call of a black hole.
That's
so it's kind of also a very
yeah. Because you're going to get a black hole out of it no matter what kind it is. I was mostly talking about the long gamma ray bursts. The short gamma ray bursts have become very popular lately. There's not as many of them as the long gamma ray bursts. Most of them end up in the long gamma ray burst catalog. But the short gamma ray bursts of the colliding neutron stars that form them have finally been detected in gravitational waves at the same time as in the visible part of the spectrum. It was the very first type of object that we saw both in gravitational waves and in the regular electromagnetic part of the spectrum from the same source at the same time. So all of a sudden, there's a whole bunch of renewed interest in detecting short gamma ray bursts and trying to correlate them with gravitational waves. So that was a very cool discovery that happened a couple of years ago, thanks to the Swift Observatory and the LIGO project.
Very cool.
Yeah, I think it was 2017, just before the solar eclipse, they found that first one.
So a lot of the research I did taking data is actually still being published. The last one was, I think, last one I noticed was in 2019. So a lot of the work I did for my graduate research, we collected such a large catalog of data that a lot of it is still coming out in various collections. So fortunately, I'm still on a number of papers, even though the work that I actually did to contribute to them was years earlier. Don't tell my university that. It looks like I'm very productive, even though I haven't touched it. That unfortunately in a few years now. Although I did work with a couple of students a few years ago to gather some more new gamma ray data, and I think we ended up with data from some sort of reoccurring X-ray source as well that was going off that night. So we've taken some data on those things, and I'm hoping to start new collaborations soon with nearby telescopes because the other ones I had are starting to dry up. So I'm being able to contribute less and less to these as I teach more and more, unfortunately. So yeah.
Yeah. Are there any other aspects of astronomy that you want to get more into in terms of research?
Ooh, so gamma ray bursts were actually one of the great things to be able to do with relatively small telescopes, actually. It was one of the easier ways for a small telescope to be able to make a useful contribution pretty fast. When I say small, I'm talking on the order of maybe half a meter disk diameter mirror or something like that. Small on professional terms, very large on the amateur terms. My university's only got a couple like 10-inch diameter telescopes, so we're the medium size amateur telescopes instead. So if I want to make a contribution, I'm going to probably have to make it more on the computational side. Now, a lot of my work was computational, modeling how galaxies evolved and things like that I did at NASA. And while I would like to get more involved with that, I was hoping to spend my sabbatical doing things like that. But unfortunately, with COVID, I can't travel around anymore or go work with anyone. So maybe my next sabbatical 7 years from now, I can find another collaboration to work with. I definitely like to get more involved again, but I'm actually really enjoying the aquaculture work too. I think that's really cool. And it's nice to have local collaborators as well.
Yeah, no, for sure.
Had you done a little bit of work with the sun too? Somewhat.
I did. So I talked about what I did after my first year of college. That was the two mass and the zone of avoidance. After my second and third years of college, I did internships on the sun. The first one was at Harvard University with Amy Weinbarger, who was a postdoc there at the time. Now she's at NASA Huntsville. And we worked on microflares. So we were using the TRACE instrument, which was an ultraviolet observatory that was observing the sun from space, and it was taking ultraviolet images of coronal loops on the surface of the sun. So basically, the sun is a giant bar magnet that's all twisted up. So basically, it starts with every 11 years, it has a very uniform magnetic field that kind of goes from pole to pole. And then over the course of the next 11 years, because the sun rotates faster at the poles than it does at the equator. Did I get that backwards? I forget now. It doesn't rotate as a solid ball. Parts of it rotate faster than others. And the magnetic field of the sun is dragged around with the basically the plasma of the sun. So the plasma is magnetically charged, it drags the magnetic field along with it, and the magnetic field of the sun gets all twisted up and loopy every 11 years or so, and ends up poking out of parts of the sun. So you get these giant coronal loops of plasma going up and down. You get solar flares exploding. And you also get a lot of tiny little solar flares called microflares exploding on the surface. So we were using the TRACE satellite to look at microflares on the surface and try to determine how many there were going off and how much energy there was coming out of them. What we were trying to do was use this to try to pin down the mystery of the solar coronal heating. So the sun, in the very center of the sun, is really, really hot, like 16 million degrees Fahrenheit. And as you go out towards the surface of the sun, the photosphere, it gets cool. Cool in air quotes. It's about 6,000 degrees instead. And that's the coolest part of the sun. And then you go up and up into the atmosphere of the sun, and all of a sudden it jumps back up into the millions of degrees. And nobody was really sure why that happened. And one of the ideas was that these small flares that are going off far more often than giant flares, there might be enough of these small flares going off to heat the corona. And I think that's actually ended up many years later being decided that that was actually the source of the coronal heating, was these little microflares, nanoflares going off. And we were one of the first papers that started to contribute to that by counting the number going off. So what I did for my summer project was basically learn how to program for the first time. I hadn't done any programming. I'd taken like a 1-semester course in C, and I learned how to use the astronomer language at the time was IDL, which is a proprietary version of Fortran. Everybody's using Python instead now. And learned how to program to go through this data and look for little bursts of light coming out from the microflares and count how many of them were in there. And then for the summer after that, I worked with the National Solar Observatory down in Sunspot, New Mexico. And basically what we did was we were looking at these coronal loops and measuring how twisted they are. We were measuring the helicity of them. So which way they twisted and how twisted they were, which gave us an idea of how strong the magnetic field was and how it moved around and how it moved through this plasma. So yeah, and then that also became part of
Wow.
my undergraduate dissertation, which was called "How Twisted is the Sun?" So yeah,
Twisted Sun.
yeah.
Oh,
That's so cool. How many in a day, how many of the small flares did you count? I don't know if there's like an
Oh,
average or
that's
if it
I'm not sure
if
how
it
many it was
shifts
globally.
by.
We were looking at a very tiny region and then trying to extrapolate to that. And I don't remember the time scale of
Sure,
those, but since the large
sure.
flares, depending on how active the sun is, you might get a couple of months during the most active period, and maybe a couple of year during the less active periods. These were going off more
Gotcha.
like every few minutes or so, at least
Wow.
globally over the surface of the sun, if not in one specific area. Yeah,
Yeah. Yeah.
that was actually a
Can I
fun
ask?
in New Mexico. Yeah.
Yeah, no, it sounds like astronomy has taken you so many places.
It really has. And like I said, I had mentioned earlier, it's taking me all over the world and all over the country, and everywhere I lived was really beautiful for its own reasons.
Hmm.
Um,
Hmm.
Sunspot, New Mexico was a very unique area. So this was up in the mountains outside of Alamogordo, Mexico, near the White Plains National Monument. It was about an hour outside of the city up in the mountains, and it was a town that solely existed for the National Solar Observatory. So the National Solar Observatory was there with a bunch of big telescopes, and then um, the town, which was the observatory, and the only people who lived there were the people who worked at the observatory. So the scientists and everybody, and the students for the summer, and everybody, and the people who ran the telescopes and did the administration. Everybody lived there in town. Which was on the only other place nearby was Cloudcroft, New Mexico, which is a little further up the mountain, which was a very ritzy little community. Apparently Val Kilmer had a house up there at the time. So it's that kind of place. He never came by for a tour. One of my duties as an intern was to give regular tours, and he did not come by. But well, we were very disappointed. We waited all summer for Val Kilmer to come in for a tour. But that was up, that was up
Oh,
at
go
about
ahead.
9,000 degrees altitude. That was really hard to walk around. Even
Oh,
after
wow.
we drive half a mile to the telescope because we were so lazy. We didn't want to walk up the mountain. You know. But the scientists who lived there had regular volleyball games and everything going on. They were all great shape because they lived up there and walked around at 10,000 feet all the time. And the summer interns were, we did not acclimate
Well, I was
well.
gonna say, with the solar observing, it's probably much easier on your sleep schedule. You don't need to be up all night.
Yes, that was very true. So we got to sleep at night and get up at a normal schedule during the day. Although I do remember there were often we'd wake up and there was a bull in the front yard. I don't remember who was keeping cows or bulls, but they just kind of let them wander around randomly on the mountain. And sometimes you'd wake up and you're like, yeah, I'm not going outside this morning. I'm gonna I'm gonna wait a few hours until something scares the bull away. Oh, and the mountain also had infestations, regular infestations. So basically, it was a breeding ground. Apparently, the mountains of New Mexico are breeding grounds for ladybugs and for moths. So at certain times of the
Oh.
summer, there would be moths on every single surface. We'd go around and kill dozens, if not hundreds of them every night in the house before we went to sleep. And we don't even know how they were getting in. It's not like the windows didn't have screens or something. They were just everywhere. And they often even shut down the telescopes. They would get into the gears of the telescope and they'd have to shut it down and clean everything out for
Oh, whoa.
because there were so many moths in there. It was such a weird thing. And then a month later would be the ladybugs. The ladybugs are now in the gears of the telescope.
Wow.
Really interesting
Could
place.
they not just throw a bunch of mothballs or grow some cedar or something?
There's just too many of them. It's not scaring anything away.
Too many. So, I'm curious, did you ever, I know you talked about how you had studied and learned how to speak Russian. Did you ever think that, was the impetus behind that because maybe you wanted to be an astronaut? Did you
No,
ever have kind of that desire?
no, not really. I'm lazy. I'll wait till there's a McDonald's before I go, or maybe a sushi restaurant. Yeah. I really have no desire to do that until it's like a regular trip up that people are taking.
That's
No,
fair. That's fair.
I think it was just when I went to high school, they offered a few languages. They had Spanish and French, and then they had Russian, and everybody was going for Spanish, and a few people went for French, and I just wanted something different, I guess. I didn't really want to go to that school in the first place. I was like rebelling by taking something weird that nobody else was taking. There were like 5 of us in the class, but it was really interesting. And of course, when you tell people you want to study physics, they look at these languages and they're like, oh, you should take Russian. There's a lot of Russian physicists. And there are. I had a lot of Russian and Polish professors in college. But nobody said at the time, hey, you know what? You're interested in astronomy. We put all the telescopes in Spanish-speaking countries. Nobody mentioned that. I did not find that out until graduate school, maybe, that I really should have taken Spanish instead. Yeah. But I never learned more than I needed, basically just to book a hotel room over the phone and things like that. I learned the very basics, but fortunately, everybody in South America was very friendly and always willing to practice their English on me. So we got along just fine. It wasn't like France where nobody wants to speak to you, even if you do speak French, which I didn't. But yeah, I got lost a lot in France and nobody wanted to help. But everybody in South America, they were.
Well, thank you so much, Adria, for joining us and sharing about your time with the telescopes, your work, the research that you've done, and also talking about some of the work that you're doing right now. And it's so cool to see how it ties very closely to your gamma ray burst work as well. Your life has been incredible, and I feel really grateful that you've been able to share that with us and our listeners as well.
Well, thank you so much for inviting me. This has been a lot of fun.
This conversation with Dr. Updike was part of a longer conversation from 2 other shows. If you want to catch the full conversation, we'll link to it on our Twitter and also on our YouTube page. You've been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Dr. Updike. From your favorite nerds, mask up. We wish you healthy bodies and clean air.